Guys, let's look at an example from apparent power. Here this question is asking a relay coil is connected to a 210 VRMS 50 Hz supply. If it has a resistance of 30 ohm and an inductance of 0.5 henries, calculate the apparent power supplied to the coil. Okay, so we calculate the apparent power using this formula. S is equal to VI conjugate. Now before we go ahead and do that, let's go ahead and draw the circuit, right? First we are going to draw the circuit in time domain. So in time domain we are going to have a circuit like this, and the resistance is provided, that is 30 ohm, and also we have the inductance, that is 0.5 henries. Also we have a voltage source. Okay, so this is our voltage source. The given voltage source is 210 VRMS, and also we have the frequency, that is 50 Hertz. Okay, and the resistance is provided, that is 30 ohm. So this is 30 ohm, and also we have the inductance provided, that is equal to 0.5 henries. The first step is we are going to convert this one into phasor domain, and if we do that, let's go ahead and draw the circuit first. So this is our phasor domain circuit. In this one we are going to have the voltage source. Voltage source is going to be amplitude and the angle. Since the angle is not provided, that's going to be 0 degree, right? So this is going to be 210 0 degree and VRMS. Okay, and the resistance will remain the same in the phasor domain. So this one is going to be just 30 ohm, and when we convert inductance from time domain to phasor domain, that's going to become impedance, and that's going to be j omega L. Here they have provided the frequency, and you know that omega is equal to 2 phi f, right? Omega is equal to 2 phi f. Since they have provided the frequency, that's going to be 2 phi times the frequency. Our frequency is 50, so this is omega, but impedance value is going to be j omega L, so we have to multiply this one with j 2 phi times 50, and the given inductance is 0.5. So 0.5 times 2, that's going to be 1. So finally we will end up with 50 phi j. So this is going to be the impedance we are going to have right here. So this is the impedance, we have to plug it here. So this is going to be j50 phi. Okay, now we have the impedances and also we have the voltage, so we can calculate the current. So current formula, we know that V is equal to IZ. V is equal to IC, therefore I is equal to V over Z. Okay, the voltage source is 210 divided by the impedance, that's going to be addition of these two, 30 plus J55, and that's going to give us 1.313 negative 75 degree ARMS. But as we discussed before, to calculate apparent power we have to use S is equal to VI conjugate. I conjugate is basically we change the sign of the angle, that's it. Okay, now let's go ahead and plug the values. Let's use a different color. So here we are going to calculate S. S is going to be VI conjugate. V is equal to 210 multiplied by I conjugate, that's going to be 1.313, and the angle is going to be positive because conjugate we change the sign of this one, so this is going to be positive 75 degree. And if you calculate this one, you are going to get 275 7.73 angle 75 degree VA, and that's going to be our final answer. That's going to be the apparent power. I hope this helps. Thanks for watching.